Hi guys, good evening to all. Today we are going to solve a new problem, that is lead code number 2962. The problem name is count subarrays where maximum element appears at least k times. So yesterday as well we have solved same kind of problem, but they changed some of the conditions. Here we have given an integer array nums and a positive integer k, and we have to return the number of subarrays where the maximum element of nums appears at least k times in that subarray. And we know that what is subarray. Subarray is continuous sequence of elements within an array, we know that. And here what they are asking means, see, in in this given array there will be one maximum element, right? So we have to find a subarray. We have to find a subarray. In that subarray there should be a maximum element, and the frequency of that maximum element should be greater than or equal to k. So then only it holds the condition. We have to find those kind of subarrays. Okay, let's deep dive into the approach. See, here the given integers are 1, 3, 2, 3 and 3. Okay, observe it carefully. uh, Here the main condition is, first of all, I would like to find out the maximum element in this entire array. So what would be the maximum element here? The maximum element is 3, right? So I have to find the subarray. In the subarray there should be a maximum element whose frequency is greater than or equal to the given integer k. So that's why I have found the I tried to find the maximum element here, that is 3. Okay, let's say I will iterate through entire array. At first we got 1, no, it's not equal to 3, so just we move to the next element. At I is equal to 0, element is 1, so it's not equal to 3, so there is no chance of finding the subarray here, so it is invalid. So we'll move to the next index, that is I is equal to 1. Here the element is 3, which is equal to the maximum element, right? Which is equal to the maximum element. So what I will do is I will try to track the indexes of these elements, the maximum element. I will try to track the index of this maximum element. uh, for that we'll be having several maximum elements in the same array, right? So I will try to consider one of the vector to store these elements. Consider a vector to track the index of maximum element, and you guys will understand why I'm taking this. So I will try to name it as vector vec. So I will try to push the index of this maximum element in this. What could be the index here? What will be the index? I is equal to 1. So then go to 3. Then I have seen the element is 2. It is invalid. So I move to the next index 3. When I move to the next index, here the element is 3 again. I will try to push this element into the vector. Again the index of the particular element is 1, 2, 3. It is 3, right? It is 3. So let's see how many elements are as of now how many elements we tracked in this vector. That is 2, and here the given number is k. K is equal to 2. So we found 2 elements, right? We found 2 3s in a subarray, right? That is nothing but see, here we got, consider it as a subarray, and we found the maximum element 3 for 2 times. The frequency of the that element is 2, and it holds the condition, right? The maximum element frequency is greater than or equal to, I mean it is equal to 2, so it holds the condition. So I will consider one of the variable. So let's see how can I find the solution here. Okay, we know that in our vector we will be having 2 elements. those are 3's and are the index 1 and 3. So my answer can be, we know that the answer is must 1, right? Because if I found one of the subarray, that is, I got the two elements, right? Let's say it is the subarray for sure, because I track the indexes of two elements, that is 3 and 3, and its frequency is 2. So I know that the answer is 1. So what I'm going to do is, let's say it also can be my answer 3 2 3. We know that it for sure it is the answer, that's why I added 1. So it can also be my answer. So how can I find that how can I find that the elements which are present before the first maximum element? So I can do it by using vector of, what is the size of this vector? Size minus k, right? So what it will gives, it is equal to 1 plus vector of, it gives vector of size 0, vector of size is equal to 2, and 2 minus 2, it is equal to 0. Vector of 0, 1 plus, sorry, give me a minute. 1 plus how many elements are, yeah, vector of 0 is 1, right? It's going to give the answer 2, because see, the elements present before this are only 1, so it has given 2. And let's say I will move to the next index, that is I is equal to 4. I is equal to 4, found the one more element at I is equal to 4, the element is 3. I store it in the vector index 4. Let's say now also the vector is the vector size is greater than or equal to k, right? So I found one more element, that is my answer can be, see here, my answer can be 3 and 3, right? My answer can be 3 and 3. So for sure, you know that the answer previously hold the value of 2, and I know that I have found one more subarray. So I will count those elements, I will count those subarray, it is going to be 1. So how many elements are there before this? Let's see, how can I find it? Vector of size is 3 is 2, it's going to give 1, right? 2 plus 1 plus vector of 1, how much? Vector of 1 is 3, it's going to give 3, because see, before these two elements we will be having few more elements. I can consider this into the subarray, right? It won't affect anything. So I'm going to get the answer as finally 3. Hope you guys, so you got my intuition. With the time complexity, I'm not using any extra loop, so the time complexity is often, and the space complexity is going to be, in worst case it is also often, whenever let's say the entire array contains the duplicate elements, that is the entire array contains the same kind of elements, so we have to store all these elements in the vector. So it is going to, in the worst case, it is going to take the space complexity as often as well. So I'm going to code it, you guys will understand. Let's say I'm going to consider an answer. To track the indices, I am going to take the vector is equal to 0 less than num start of size, and okay, I forgot to find the maximum element here. We'll be having one STL method to find the maximum element. You can simply use that. Begin. And then whenever I see the maximum element, I'm going to track the indices. I'm going to track that index. And then let's say if vector dot of size is greater than or equal to k, yeah, found the subarray. Simply what I can do is vector of yeah, that's it. Let's see that will work or not. Sorry. Yeah, we have submitted the solution and successfully completed it. That's how we can do it by using the sliding window approach. But since 2 days, from the last 2 days, I've been using the sliding window technique. So just I want to change the solution. So you could try that method as well, and that is going to take the space complexity of 1. Sorry, and thank you.